So last time we looked at the pipeline without any data forwarding units, but most of our code we have to handle with its data hazard and control hazard all the time. So inside of the hardware, what's going to happen? We'll take a look at it from this example. So these are the how to handle data hazard. This is the no operation, just delay by 2 clock cycles. And if we are using forwarding unit, the forwarding unit is coming from the memory. So when we look at the diagram, it'll be more clear than this. But basically, we're forwarding from here to here because we need to update this R1 after we add these content of R4 and R5, put it into R1. That R1 is actually available 4 clock cycle later. However, following clock cycle, we need that updated R1 right here. So that's why we need to forward it from here to here, and then also from here to here, because R1 is also using in here. So book talks about all of these equations. We don't have to worry too much about it. Inside of this hazard detection unit, we have this type of diagram. Always we compare Rn and Rm in the previous stage with the Rd in the later stage. If they do match up, meaning they're going to need this updated Rd values in their input values. So this is the complete diagram, and we're going to work on these 4 instructions. So we're going to start with the cycle number 3. Cycle number 3, the first instruction is execution stage, and instruction is ID stage, and then OR instruction is IF stage. In the add instruction, right now nothing is happening, right? Because I didn't have any instruction in the previously. We don't have anything to compare. So contents of R4, contents of R5, add them up, it's right there, and I'm carrying my RD right down there. And this forward detection unit, there's the 2 bits. Right now, we just need to select from the ID stage, so the control number is 0000. Cycle number 4, so add instruction is in the memory stage, and instruction is execution stage, or instruction is ID, and then subtract instruction is here. Drop your pencil, watch here. So now, we're going to compare this ID right here with Rn and Rm. Rn and Rm, those are the 2 registers. We're going to AND them and then put it into RA, right? So they do match because R1, we have a newer value right here is available, but we need to use it R1 in here, right? Therefore, this hazard detection unit, it will detect, and for that result is from here to here. Therefore, this control line is going to be 1, 0, and then second input, R3, is nothing to do with this 1, right? Therefore, we're going to just keep it, whatever we read it from the ID stage, I'm going to just keep it in here. So this R1 is the updated value, R1 from this cycle. This output is going to be R4 and R5. No connection from here to this diagram. Right. This book doesn't show anything, but the actual diagram is this guy. So for the hazard detection unit, you need to pay attention to these 2-digit values. So that's something I'm going to ask. This value is 00, this one is 10, based on which one is going to be forwarded. This stage, we're going through this AND, R8, R1, R3. So we need to AND content of R1 and content of R3, AND them bit by bit, and then put it into R8. That's what we want to do. Oh, R4 and R5. Oh, just this. Typo, sorry. Anything else? Cycle number 5. So we have add instruction as in the write back stage. Now we're going to add R4 and R5, store into here, and then our RD value is 1. So we're going to say as a A3, and we need to update the value for R1, store there. That's what we're going to do. And then at the same time, we have R1 in here, right? Or was in this stage, he got the R1 value from here, but we haven't updated yet. So we are updating right now, but this R1 is old value, right? Because one cycle before. So again, we need to forward this into here. In the previous cycle for this guy, R1 was in Rn. That's why we need to update this guy as a 1, 0. But this time, R1 is Rm position, which is the second register. So we need to update it in here. Okay, so that's the difference. So the top one, we're going to keep it as an R6. But the bottom one, we're going to get it from here. Therefore, this is 0, 0, this is 0, 1. So we're talking about these guys. Exactly. Yep. I didn't put it in here, but for example, for every stage, we carry out their own control line through this storage space. So we had it before. I mean, some of those control line is not applicable in the future stage. That's why we have only 3 now. You need to understand all of these numbers as well. Okay, so let's go to cycle number 6. For the cycle number 6, so now we have subtract R1, R7. For this one is okay because when we execute this subtract, even though we are updating R1 in this same cycle, but we are okay because we're going to write first in the half cycle and then read it in the second half cycle. Therefore, whatever this value R1 and R7, if it's somewhere from the write back stage, we are okay because we're going to update it before actually we write it. So that's R1 and R7. These are some of the control line that I'm showing you as well. This is the cycle number 6. So I didn't highlight any of those, but it's going to go bypassing for the result. So this is the highlight, the path for this OR. And this is the ALU result as a subtract. So content of R1 minus content of R7. And obviously this forwarding unit is all 0, 0, 0, 0. For mem write, it's going to be 0, right? We are not writing anything into it. Mem to reg is going to be 0. We are not going from memory to register, which is the value right here. And this register write is going to be 1 because we are writing back. This is 1. And PC source is going to be 0, typical PC plus 4. 1 is for the branch. Now, let's say when we have this guy, these are the series of instructions. We need to read R4 and then add 40, and we need to go into memory, go into this memory, read it, and we're going to update R1, contents of R1. Make sense? That's what we do in LDR. The problem we have is the following instruction. The following instruction, and we want to have the content of R1, the updated content of R1. But that is available after memory access. So there is no way, because in this diagram, after we access to the memory, we need to get the value from here. That's the result, this guy. So when we have LDR and followed by one instruction, it's going to use the result of this LDR RD content. There's no way but we need to fit into one bubble. So we need to store one cycle. That way, this LDR result is available in this stage, and then we can forward that into an instruction. I want you to copy this down, write this series of instructions, copy this down, and have the table something like this. For the first instruction, LDR, R1, R4, and 40. We're going to add the content of R4 and 40. That's the memory address that we're going to need to go. And after we access to the memory, grab the content of the memory and put it into R1. R1 is available in the write back stage. And write back stage, if we don't put the bubble, there's no way we can forward it write back stage to EX stage. It's backward. Reason we put in the bubble right here is because this content of R1 is available write back stage, so we're going to forward it to EX right there. So content of R1 is going from right back to EX stage. And since we put the bubble in here, that's going to affect to all following instructions. That's why we have a bubble, all of this. So this is the only case when we have a LDR instruction. Only case with the bubble. If there is any other instructions, we can handle with the forwarding unit, but we cannot handle with the forwarding unit when we have a LDR and the following instruction really need the updated value as an input. Only LDR case, we need to put the bubble. Good? Yeah, this is the only case when you have a LDR followed by one instruction that is going to use the RD of LDR. We want to use it as a source, then we need to put the bubble. That's the only case. Yeah, right. So the actual example, we're going to look at it in the pipelining, okay? So this is the logic that you can take a look at it. So we're going to go through these instructions. By the way, for this guy, this is the one format that I can put it into exam. So I'm going to say using traditional diagram for the pipelining, and I'll give you the first line as IFID, EX, MEMP, WB, and then you need to fill the rest. Okay. Put it in here with the forwarding, which one is from where to where you're actually forwarding the content of what register. You need to tell me all of those in the exam and then final exam. So this is the cycle number 3. We have a LDR is in the EX stage. So the typical reading from R4, okay, so it's going to be 0, 0. And we are using number 40. So that's from immediate value from here. So that's the 40. So we're going to add content of R4 and 40 together there. And then we're going to carry this 1 as an RD. Now I'm showing you the control unit right here. So this guy, ALU source E, is going to be 1. And then for ALU, control E is going to be 0, 0. Because we are adding those two. Addition is 0, 0, subtraction is 0, 1, N is 1, 0, OR is 1, 1. Those are the 2-bit ALU values, control values for ALU control E, this line. And in the same cycle, we have N instruction in this ID stage. So we have 1 and 3 RN and RM, and we have 8 RD carrying in here. Now, in the same cycle, what's going to happen here is we're going to check for R1 and R3. So the RN values and RN values, these guys, with this RD value in the LDR. And we know in this cycle, this instruction is LDR because we know mem read, mem to reg. This guy is going to be 1. This mem to reg is 1 only for LDR instruction. So by looking at this bit, LDR is in this execution stage. That's how we detect it. Make sense? So now we know LDR is in this stage. And now compare this RN and RM with this RD. So this compare and there is a match. RN and RD, they do match. Then what's going to happen here in cycle number 4, we're going to activate this flush and we're going to move LDR into memory stage. However, because of this guy, hey, N instruction, you need to stay. Okay? You need to stay and activate this guy and clean up whatever we have in here in the previous stage, clean that up. So this is the one effect of one cycle stalling the following instructions. So this is what's going to happen in cycle number 4. So you can put the bubble, make it some bubble sign or write the bubble in the EX stage. So we're going to flush that out. Yeah. RN and RM with RD. In cycle number 5, now content of R1 is available and we're going to write back right into this register file. But at the same time, in this N instruction, we need R1 new value, right? Updated value. So we're going to get it from here. So this time for the E control value is going to be 0, 1. And the second one is just regular from the register file. So we're going to have a 0, 0. So this is the cycle number 5. No, no, you don't have to. So because it's just empty, showing there's a bubble. There's nothing happening in here. Cycle number 6, the last diagram that you want to put it in. Since we had the bubble, there's no instruction at the write back stage. And we're going to bypass this memory for an instruction. And then OR instruction is going to get this. And I didn't highlight anything on the here. Now, you know, it's just regular data processing.